Now we want to take the derivative of our t of t vector, and we'll see why this is important. We're actually going to see why this vector is perpendicular to the curve, and we'll see that fairly shortly. But let's just worry right now about the technical problem of taking the derivative of this, which is not a trivial task. It's not as bad as it could be. It's not quite as tedious and quite as long as many, but it's long enough to illustrate that these derivatives can get a little bit complicated. However, it's a derivative. It's just a process of applying rules. There's nothing creative about it. You don't have to have any imagination. You just have to be able to apply the rules. Unlike excuse me, integration, where you've sometimes got to be very creative and try a lot of different possibilities, there's a straight path through the process of differentiation. We first recognize that this is a quotient. It's one function divided by another, so we're going to apply, naturally enough, the quotient rule. So this equals, and just going to write it out, it equals the numerator function multiplied by the denominator function Now this numerator is going to be long. It's not going to be written on just one line. So this is, and actually said the derivative of this function. Okay, so here's our, if this is f over g, here's our f prime times g minus our f, which is negative 3 sine of omega t I plus 5 cosine of omega t j times the square root of 9 plus 16 cosine squared of omega t prime. Close the brackets, and we have our numerator of the derivative function. The denominator turns out to be quite simple. It's f prime g minus f g prime divided by the square of g, and the square of g is just the square root of the square of the square root of 9 plus 16 cosine squared omega t. So the derivative, or the denominator of this derivative expression is actually quite simple. Now we just have to take this derivative, which is an easy derivative, this derivative, which is going to involve a chain rule. It's the square root of a function in which one of the functions is itself a function of t, so we're going to have to apply the chain rule 3 times, but this is a fairly straightforward derivative. Even considering that, there's nothing really difficult in the process of taking this derivative. And we'll do that in a minute and see what we have. But we see that, again, numerator, denominator, derivative of numerator times denominator minus numerator times derivative of denominator over the squared denominator. The product rule for functions of single variable is just f prime g minus g prime f over g squared, essentially. This rule is applied here where the denominator is a vector function, but it's easy to prove that even if the f here it happens to be a vector function, that the rule still applies.